Manchester University can test how rainwater may influence the path of a lightning bolt. First, a dry tube is filled with salty water. This represents the conductive fluids inside survivors' bodies. Then, strike the tube with a lightning bolt of similar size to a direct hit. This will show how the lightning could travel across a dry human body. While lightning does flash over the outside of the tube, some still thunders through its center. Evidence that the lightning traveled this path is obvious.
What we saw at the bottom of the tube was lots of holes being made by the lightning trying to get out. And that is similar to what would happen to your body. Again, at some point it has to get out. And it will often do this, say by your feet, make a hole in the skin, and it will get out into the soil.
But how will the lightning path differ when the outside of the tube is wet? Take an identical plastic tube and spray it with water to represent rain-soaked bodies. Will more lightning be conducted round the outside of the tube, illustrating the heightened level of flashover?
When we have the tube that's wet, the lightning travel down the outside of the tube. So if you are wet in a thunderstorm, lightning is more likely to flow on the surface of your skin or on your clothes than it is to actually go inside your body.
Side by side, it's clear that more lightning does flash over the outside of the tube when it's wet. So when a person's clothes and body are wet, the path of the lightning is more likely to be over the surface rather than through the body. But how will this path change the damage generated by the current?